Hi everybody, this video is intended to help you with using the TI-84 in an effort to help understand linear equations better, how to write regression lines, and how to use the graphing features of the TI-84. So the first thing I want to show you is how to turn the calculator on. In this video, as we're going through some of the steps, I want you to notice that the buttons on the left will actually stay highlighted for the last button that I push. So on, right here, if I push on it, it'll be red. So if you miss a keystroke, just look for the red button, or you can rewind the video and watch it, but the last button that I push will always show up in red. Alright, now, sometimes when you get into the calculator, it has like a screen that's on. For instance, this screen might show up here. If you want to clear your screen, or if you don't want to see this and you want to go back to the home screen, you just push second, and then anything in blue here, when you push that second key, can now be accessed. So if you see above the mode button, it says quit. So we're going to go the second key and then push that button, and that will actually quit us out of any application that's running. Sometimes there's like calculations on the screen and you don't want to see those anymore. You can just hit the clear button and it will clear everything. Interestingly enough, though, it's still in the memory. So if I wanted to see my past calculations, I can just hit the up arrow and it will actually show me all of the work that I've done since the calculator was last used. And I think on the ones you're working on, it actually shows all the last keystrokes. All right, so our first job is to take the data that you collected from the Bungee Barbie lab and enter it into essentially like an independent and dependent variable list. All right, so the way we do that is we go into the stat menu, and the stat menu is right here. So after you push that, it's going to give you the option to edit, do calculations, or perform tests. We are at this point going to edit the list, so you can either push the number 1, or since the one's already highlighted, you can press enter. And then it should pull up a couple lists. Now, some of you may not see L1 and L2 at the top. All right, and so I'm going to show you how to reset the calculator so it does. If your calculator already says L1 and L2, you can kind of fast forward through the next, I'd say 30 seconds or so until you see me get back to the screen, and we'll start putting numbers in. So if you need to create your screen to look like this, if you have different names here, you're going to go into the memory button, which, see how this is in blue? So that means we're going to push the second key, hit that plus sign, which says memory, above it. And then in the memory list, we are going to reset the memory. So that's option 7. So I just pushed the number 7, or I could have arrowed down. And I'm going to clear the entire RAM. So I'm just going to press enter to select option 1. It will ask if I really want to do this, and I'm going to indeed say yes, I want to reset. So number 2, and it cleared everything for me. So I'm just going to push the clear screen, or the clear button, excuse me. And then now to get back into my my list that I'm trying to build, I'm just going to go stat, and then edit or enter. And here we are. So now everybody should see the same headings. Okay. All right. Now, our data from the lab is going to be this first set of numbers here. That will be our independent variable. Or in this case, we're going to call that our L1. And then our dependent variable is going to be L2. So I'm just going to enter L1 to begin with by pressing the number and then pressing either enter, or you can arrow down. You can press enter, or let's see, 4, 5, 6, 7. Okay. Now to get to the second menu, we're just going to arrow to the right, and now we're going to go back to our chart, and we're going to enter. And again, I just made some numbers up here. You should have 3 different distances for each rubber band that you added on, and then this last column is the mean distance. So I'm just going to type those numbers in, and I'm just going to split my screen here so we can try to do this without flipping back and forth so much. All right, and see if we can get both windows visible. There we go, and I'll slide this one over. There we go. Okay, so let's see, my list. I'll go ahead and enter mine. You can type yours in while I'm doing mine. Should notice on your data that the more rubber bands you added, it did increase the distance that Bungee Barbie traveled. Also double check on your last data entry that there are the same amount of items in L1 as there are in L2. And I definitely have that in my list here. So now that I've got my data entered, we're going to press the stat key again. And then now we're going to arrow over to the right under the calculations menu. We're going to calculate what's called a linear regression. All right, and actually before I do that, I want to show you why we're doing a linear regression. Let's see, I'm going to go back to my data. Let's go back to edit. And looking at these values, when we go to scale our axes, I'm going to create a graph of this data in the calculator. But I want to make sure my scales are set appropriately here. So looks like 44 is my biggest. This is essentially my Y value list. And then over here are my X's. So if you go to your window settings, X min means what's the smallest number in our X list. Basically, what was the smallest number of rubber bands that we used? We want to make sure that we are at least that small, if not smaller. So I'm going to choose 0 for the minimum, or you know what, I might even do a negative number. So I can just hit clear. I'm going to do -1 and make sure with the negatives we choose this sign, not the subtraction key, otherwise it will cause an error. X max would be how far to the right do we want the X axis to extend. And I think if we extend over to 10, that would be fine. X scale means what are we going to count by. So in this case, I'm just going to count by ones. The Y values, just to refresh your memory, come from L2. So looking at these numbers, remember we always want to start our scale at 0. So I need to at least go to 0, and I'm going to probably go from like 0 to 50. So in my, in my window setting, if I go back to my window setting, let's see, I can start it maybe at -5 or 0, but I like to be able to see the X and Y axes. So I'm going to go -5 to, say, 50. And I'm going to count by 5s. All right, and then now when we hit graph, I don't think we're going to see it yet. But we can see our scaling here. So this goes -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then on, remember that y-axis we scaled by 5s. So this would be -5, 0, 5, 10, 15, 20, etc., etc. All right, now to get our points to show up, we can go up to plot. So I'll show you that again. I went to the Y equals menu. And if you turn your plot on, basically you just hover over the word plot and press enter. And you'll see that plot is now darkened. Okay? If we hit graph, now we see the points that were there plotted on the screen. So this is essentially what your data should look like on the handwritten graph you created. All right, it's just a digital way to do it. Okay, so this is a way to graph it. Now, if I want to come up with the equation or our math model, to me this looks like it's pretty linear. It's a straight line. It looks like a positive slope, and our y-intercept, I'm going to guess, is somewhere around 10 or 15, something like that. Okay. So to confirm those numbers, we're going to go back into your stat menu, and we're going to arrow over to calc, and we're going to do a linear regression line. Okay, so option 4. It's asking what numbers we're going to use for our regression line, and this should be set to a default of L1 and L2. Don't mess with those. Just go ahead and hit the enter key or the down key, and then just ask it to do the calculations for you. And then just so hover over calculate and then press enter. And here we go. This says our equation is y is equal to ax plus b. Okay, so what does that mean? Let's first look at what that means with our math model. Again, I'm going to go 2 windows on you so we can see this better. All right, so I'm just going to clear a new page. They've written their math model as y equals ax plus b. All right, and I want you to think about that in terms of what we've done. So output equals slope times input plus y-intercept. Okay, so our output was number of bands, or I'm going to say bands. How about rubber bands? I like that better. Rubber bands. Actually, okay, let me rephrase that. How about number of bands equals our slope? Well, slope corresponds to A in the math model. So if we look over here, we're going to have to round this, but our A value or our slope would be 5.2, and our units for the slope were, let's say we did inches. I don't know if you did inches or centimeters, but inches per band. All right, there's our slope, times our independent variable, which was, the bands were the independent. Forgive me, the bands were the independent, and the distance, I got that goofed around there. The distance was our dependent. Okay, so 5.2 inches per band times the number of bands plus our y-intercept, which in this case they used the letter B, and they said that was about 7.9, I'm going to say 7.95. 95, and since we use inches for our slope, we're going to assume we're using inches for the y as well, y-intercept. There we go. So there's our math model. Okay? Write your math model down, pause the video, and record that. Okay, now that you've written your math model, the last thing we're going to do in your calculator is to go to the y equals menu, and we're actually going to type that equation in so you can see the line show up. All right, so our equation, again, I'm just going to slide this up so you can see both of them. Our equation is essentially the right side of this. You see how they already wrote the y? Y corresponds to their y value, which in our case is distance. And then after the equal sign, we're going to type the right-hand side of that equation. Okay, so y equals 5.2. The TI calculators can't handle units. Times, that's your asterisk key, 5.2 times x. Now you can't find the letter X in green. Instead, what you want to do is use this button right here, and it's highlighted in red. That's always going to be our variable button. And then we're going to add in the y-intercept. So if you look over here, plus 7.95. So this is going to graph that model for us by just pushing the word graph. And look at that. There's your line of best fit. So here's our y-intercept, which was supposed to be 7.95. Okay. And then our slope, we don't see that value necessarily other than the fact that it's positive, and we're increasing 5.2 inches for every one band that we added on to our Bungee Barbie. And that is it. Take the time to try graphing this, and then let me know if you have any questions.